Hello, everyone. Hi, my name is Chung Hua. I am an architect, and I've been building the cloud big data platform for quite a while now for clients such as Sainsbury's, HSBC, Royal Mail Group, Sky, Vodafone, etc. And these are across various platforms. So basically, I've been building a big data platform since the Hadoop ecosystems, and now we kind of move on to the Azure, GCP, and AWS. I've also worked with Google as part of their team as well to build these platforms. So today, what I'm looking to do is to kind of bring out, all these different components together and see how they flow through the big data platform. Because I guess once you kind of build this a couple of times, conceptually they'll kind of see just different technologies plugged under the hood. So let me begin this. So normally, what's the motivation behind the cloud big data platform is normally the requirements are normally you want something that's self-service. You want to pay for storage and processing. You want to separate the processing and storage. You want to make pluggable business logic. So what this basically means is you want to be able to do the processing, pluggable, that kind of thing. You want multi-tenancy. People are asking for multi-cloud. But the most important of this is actually making everything data-driven. So what I want to do here is just kind of give you a quick history. This might be, simple for some people. For those who's new, this might be interesting. But I'll explain to you what data-driven architecture is, and then I'll show you an example of how this all kind of ties in together by plugging a technology just such as GCP cloud platform, and then I'll show an example what it also looks like on a AWS. So what is a data-driven architecture? So I've been around for quite a long time, and for those people who's been around as well, I don't know if you remember the days where we have many systems, and these systems kind of talk to each other, integrate with each other. So you're kind of spending more time integrating with each other with spaghetti kind of architectures like this. And then someone comes along and say, let's start building an orchestration pattern, the ESBs, the workflows, and have all these spaghetti stuff in one place. So that's what we kind of move towards. But the problem is you haven't really got rid of the spaghetti, and it's hard to reuse things. So you kind of just contain it into one place. So then we move next to kind of more like the data platform, looking more towards the kind of event-driven pattern. So you've got all these systems who are the master of their own data source, and you want to somehow push data into this big one place. So let's not move the data around. So this is similar to the kind of the microservices architecture. So just a quick example of this. Let's just say that I have a product that I'm building, and the product itself is the master of this of his own data, and so with the data platform, I want to push my product service into this data platform. With a product, I need a customer. So I might have a CRM, to bring my customer together, and with this customer, that you can also push data into the data platform. As you can see, the product and the customer, they don't need to know about each other. Well, all they need to do is just push their data into here, and then we might have an inventory service. So this service needs to know about the product as well, and so again, this can subscribe to the product service, and it also pushes its own inventory service into the platform. And then once you also need an order service, as an example. The order service needs to know about the product, the customer, and the inventory. So again, these systems are not integrating with each other, but they trying to understand the data. So it's all about the data. And again, the inventory service will probably need to subscribe to the order service to understand what the order data is all about. So then it can update itself eventually. Okay, so let's move on to the big data platform here. This is kind of the very basic conceptual view. On the left hand here, you have the data sources that you normally push into the big data platform, and normally you land into this kind of the landing area. Yeah, so this is where you kind of your raw data. In the heart of this is you've got this kind of orchestration piece, which helps you to build your pipelines, which allows you to move the data. You prepare your data, you might do some obfuscation, but effectively you want to put it into a data repo. So the difference between the landing is that you've got lots of the kind of raw data. It's almost like your data lake, but the data repo is something that you trust. You've done some cleansing, you've done some work on this, so it's more trustable. And while the data is being moved across into the data repo, what you're doing at the same time here is you are tagging the data catalog. So the benefit of the data catalog is really for allow anyone to be able to search within your organization for all the data that's that's sort of landed here and data that's stored in here. And then the next bit is you have the business logic. So this is where you do your processing, which you take your cleansed data and then you might do some more processing, move it to another data tier level, turn it to some common entity, and then from a common entity you might start processing and turn it into more like a star schema, some sort of common data warehouse processing. And at the end of this is your consumer. So your consumers could be your data scientists or even your business intelligence teams with tools like Tableaus and Power BIs, etc. That kind of thing. So that's so the key bit here is actually the business logic where you can do processing. So now if I introduce a technology as an example here, let's just say that we've got we're building a big data platform on GCP, Google Cloud Platform. So so this is not about the technology here, but it's more about these pink bits, these kind of what I called reusable bits, reusable services that works across the whole platform. So here you've got the landing. So in terms of Google Cloud Platform, you might have something like a GCS bucket. You might have pub sub, for messaging, etc. And so you can do sort of real-time streaming at the same time as well. And then you might have other technologies to do your processing, like Dataflow, Spark, which is a data proc, Google kind of technology. So so effectively the data lands and goes through all of this and ends up in the data repo where you make it available to the people on the right. So in order to make this easier, I thought I'd animate it for you. So in addition to that, I haven't really mentioned about security. So in most organizations I've kind of built big data platforms for, they normally have an Active Directory, and then this the user in the Active Directory would get synced into, depending what cloud you're on. So this is where your Active Directory used as synced, and then you can start using the cloud. In addition to that, what we also have is logging, monitoring, auditing alerts as well. So again, these are captured and can be integrated with your ticketing systems, your supports, like ServiceNow, etc. That kind of thing. So these are kind of the key components that you need. So the first thing what you want to do is to be able to ingest data into your platform. And here's an example. So effectively from the source system, you land a piece of data. Normally with a piece of data, it comes with some meta information to describe what the data is all about. And in some places I've worked with, it also describes what you want to be able to do with this data. Do you need some cleansing, some data quality? The data, what is this data about? It's a customer data. If it's a customer data, are there any PII data, etc.? So do you need to do any obfuscation before you put it into this data repo where you trust it? In terms of orchestration, some cloud providers, in Google they have Airflow, but you can use your own bespoke one. So when the data lands, the orchestration kind of wakes up effectively. It knows about the data, and you're looking at the metadata, meta information about this data. Think of it like a passport that tells you, here's a piece of data, where it came from, what source it came from, and what you're looking to do with it. So, optionally, this data will then be moved into preparation. If it's sensitive data, you might want to do some obfuscation with this, and then you would put it into the data repo. Yeah, so this could, so now it's ready to be consumed and processed properly. So at the same time, while you're moving through that, you're tagging the catalog as well. Yeah. So the catalog allows people to search for that. So I'll demonstrate that in a moment. Okay, so the next bit that we would have on the platform here is the processing and the analytics. I call this a business logic. So this is kind of like the pluggable component that you can plug into the platform. So if you look at this, the business logic now is really just consumers of this data repo because we know that the data has landed, you've done some cleansing and data quality, and now it's ready to be consumed. And if you look at this kind of the business logic, what we're looking at here is you can have different people subscribing to the various data catalogs, to search for the data catalog, and to subscribe to data that's landed on here as an example. So that's where the kind of the data catalog comes in. So when new data has arrived, you might have some sort of notification that tells you that you have new data, and then within your kind of business logic, you would pull this data into your own area, and at the same time, you might be also interested in real-time data. So this is where you want to join historical data and with real-time data as well. So this effectively, you join the two, and you might do some processing. So this is kind of optional with the real-time, by the way. And then once you've done your processing, you would make this available to your consumers here on the right. Yeah, so this could be your BI tools, your Tableaus, etc., or you could forward it on to the other channels. But this piece of data that you done some processing, being a good citizen, you might think, well, this could be useful for publishing back into the data repo. So there's options. You can publish it directly back to data repo, or you can publish it through this channel. But either way, the data will again get tagged across into the data catalog, and it goes through the same process. And basically, you can search for this new data that gets published back into here. So again, you actually could build data lineages from data that's landed, just by tagging this, and because this, whatever you put in data back into here, it has some metadata that describes the data, where it comes from. You can actually build this. So in certain companies, you can build like a graph database, which kind of links all these metadata together and provides you that kind of lineage. Okay, so I'll go in a bit more details around the business logic bit but effectively, if you can break this down into three high-level project types. So the first project type, or what I call kind of productionized projects, business as usual projects. So these are kind of automated. These are all kind of DevOps driven. So we would use, for example, CI/CD, Terraform Terraform to build the infrastructure for this project, and using CI/CD to deploy the code to these projects. But these are projects actually automated. So as data lands into the system on a periodic basis, it will pull the data because it's subscribed to it, and it processes it, and updates it. The next kind of type of projects that you can have is what I call exploration projects. So these are more like your sandbox projects. So the whole idea of having your big data platform on the cloud is to be able to access the data repo data with your own sandbox. You pull the data in, play around with it, and then at some point you think, well, this could be useful, so I want to promote it to become a business as usual project. That kind of thing. So where we have DevOps or CI/CD, that kind of thing, the beauty of this is that you can have different patterns or different projects and tools for different types of users or personas. So if I was a business intelligence, an analyst, I might have a sandbox project which contains all my tools to use for my own data exploration. If I was a data scientist, I might have a set of my own kind of projects with the right tools that I can use. So this could be Spark, notebooks, that kind of thing. So you can have different tools for different people. So these can be built up over time, and it's simple as just requesting, through some ticketing system like ServiceNow to say, I want this project spin up, I want access to these data in here, and then the platform could use Terraform to spin up these up quickly for you, so you can play around with it. The third type of project, what I call application projects, apps projects. So with an application project, what you have here, you can actually build applications. So it's just not about big data. Yeah. So this is, you can build your microservices, your APIs. And again, these projects can push data back, into this data platform. So I'll give you a very quick use case. Let's say that I am a data scientist, and I'm working for Sky as an example. So this is one of the companies I work for, and I want to be able to build a machine learning model to work out the top 5 things that that people watch. Okay, so that's kind of machine learning model. So I would subscribe to some of these data that I have already in here, and I would build my model. And then at some point, I said I want to be able to promote this to become, a proper model. So this gets promoted to become a proper business as usual project. So you continue taking data in, and you continue improving your model. But the process of moving this is more around, working with the data engineering, adding security around this, automating this, productionizing it to a good quality. And then I could be building an apps project for my call center as an example. So let's just say that from the call center, my name's Chung, and I'm a Sky subscriber, and my subscription to Sky is ending soon, and I'm looking to cancel my subscription because I think it's quite costly. So I would call up the call center and ask them, I want to cancel my subscription. So we could build an app here, which basically the call center could link to, which effectively looks into our data repo to find out what offers we have available at the moment, and also looking at the recommendation to see what the top 5 things that Chung like. So one example would be, okay, Chung likes watching Premiership football, Sky Sports as an example. And there is actually a current offer. So as part of this app, it joins the offer together with what's available and what I like. So effectively, there's an offer to give you 6 months free of Premiership football. So the call center person will say, oh, by the way, if you stay with us, we could give you an extra 6 months of free Premiership football. And Chung might say, okay, yeah, that's great. I'll take the offer, or I might turn it down. But again, this app could also be pushing data into here to learn as well. So effectively, we've had this kind of data that does this. And the key thing is these free the apps here. The beauty of this is, you can deploy serverless architectures, or you can deploy other applications on here. But you can, deploy things in parallel to test and throw away. So it's all about fail fast as well. So let's recap the big data platform. What we said was we wanted one place to publish and access the data, real-time and historical, and we want a way of knowing when the data has arrived and have access to it. So if we look at this kind of conceptual view, what you're looking here is you've got one place to publish the data and access the data, and also it supports real-time as well. So this is kind of a high-level conceptual view for that. And then if you were moving to another cloud, here's another example implementation. So on AWS, you would have your landing. So you have you said that you have your S3 buckets. You would have your notification service for streaming. You can have Kafka, or you can use Kinesis, etc. So you can have step function to your orchestration. You can have your data catalogs, etc. So it's really up to you what technologies you want to put under the hood. With Azure, it might be different, but effectively, in terms of processing, you can even put in other things as well, like even Dremel or whatever you need. You can build your microservices using your apps projects. So yeah, so that's kind of like the high level view of things. So that's it. Any questions and feedback from this? Yep. So I've got a question here by Tim. So he says here, very interesting. How did the data platform look before this transition? Are you able to onboard the same process, or did you have to build a new team? Question is, can this type of transitions be made with house resources deeply steeped in SQL and relational? If not, what does the learning curve look like? Okay, so for this data platform, I guess it comes down to your company and what technologies your company already supports. So in some organizations, they have a strategy where they want to use GCP. In some others, like Sainsbury's I work for, they want to use AWS. And I guess with these new technologies, if you're not very good on the cloud when you first start off, then you need to either train up the people, or you would hire new people. So yes, you do need a new team to work with this, but there's no harm in bringing experienced people working with existing teams, so they can learn from that. What I also done is that after a while, this kind of conceptual architecture can be built up pretty quickly by using something like Terraform, where you I guess this could be done in another demo where you can actually build the platform that I've just mentioned here, purely spinning up the infrastructure as a quick proof of concept using Terraform, which builds all these kind of buckets, clouds, areas for you, data to land, and you can actually have a data that lands and then it goes right across. So I actually have patterns for that, and I actually have demos, to build it for GCP, for AWS and Azure as well. So that can help you to get up to speed quickly. So in terms of, so the next question is do you have any recommendations for the data catalog? So in terms of data catalog, one of the popular ones that most of the big organizations I noticed are using Calibra. So that seems to be a popular one. But if you're using Azure, you can use the Azure Data Catalog as well. So so one company I work for uses that. It really comes down to preference and what is your kind of big data platform strategy is. Some companies I work for, they want to go kind of fully managed service. So that means you don't want to be able to spin up your own platform. You don't want to be able to look after it. So you would go for something that's already supported. There are other companies where I worked for where they, on GCP, where they actually use the data catalog of GCP, mainly for everything that's on GCP, and then they actually integrate the GCP data catalog with the Calibra one as well, because that was the kind of the de facto one that's being used by the company. So there's different ways of doing that. Okay, cool. So I think that's the end of our session. Thank you very much.